Hey everyone, and welcome. Today, we are going to pull back the curtain on a tool that is absolutely essential for anyone who builds software, the UML Class Diagram. You can think of it as the master blueprint that helps us turn a really complex idea into clean, well-structured, and working code. So, let's dive right in. So, here's what we're going to cover. First, we'll start with the big picture idea, the blueprint. Then, we'll zoom right into the single most important building block, the class. After that, we'll see how all these blocks connect to each other, look at a complete real-world example, and then wrap it all up with why this stuff really matters. Okay, section 1, the blueprint for code. Look, before you can build anything truly great, I don't care if it's an app or a skyscraper, you have got to have a plan. And not just any plan, but a detailed, clear plan that everyone can understand. You know, think about it. How would an architect even begin to plan a massive skyscraper? You wouldn't just show up to a construction site with a bunch of steel and start welding, right? Of course not. Exactly. You start with a blueprint, a super detailed schematic that shows every single floor, every support beam, every connection. It's the one and only source of truth for the entire project. And that is exactly what a UML class diagram is for software. It's a diagram that shows the structure of a system. It lays out all the classes, what kind of data they hold, what they can actually do, and, most importantly, how they're all connected to each other. It is, for all intents and purposes, the official blueprint for building an application. All right, let's get into Section 2, Anatomy of a Class. So now that we've seen the big picture, we're going to zoom way in. Forget the whole blueprint for a second. We're going to look at just a single room, the fundamental building block of our entire system. Every single class in a UML diagram is just a simple box. But this little box is always divided into 3 parts. Up top, you've got the class name, basically what it is. In the middle, you have the attributes, that's the data it keeps track of. And down at the bottom, you have the methods, that's the behavior, or what it can actually do. So to make this real, let's design a really simple class for a square. As you can see, that top part is a piece of cake. We just write the name of our class, square, done. Okay, now for that middle section, the attributes. What piece of data really defines a square? Well, it's the length of its side, right? So we write the attribute name, side, we put a colon, and then we give it a data type. In this case, double, so we can have numbers with decimals. Now, what about that little minus sign out front? Hold that thought. We're going to get to that in just a moment. And finally, we have the bottom section, which holds the methods. This is all about behavior. What can a square object do? Well, it can calculate its own area, so we'll give it a getArea method. And we probably want to be able to change its side length, so let's add a setSide method. These are the actions the class can perform. Okay, so time to decode those symbols. This is what we call visibility. A plus sign means it's public, anybody, any other class can see it and use it. That minus sign we saw, that means it's private. It's hidden away and it's only accessible from inside the square class itself. And this isn't just some arbitrary rule. It's a huge safety feature. By making data private, we protect it from being accidentally changed or corrupted by other parts of our program. It's really a cornerstone of good software design. And here's the most important part, the real key takeaway. This is not just some abstract drawing. The notation, side, double, on our diagram translates directly into a line of code, like private double side if you were writing in Java. The blueprint is a practical one-to-one guide for the developer writing the code. On to Section 3, connecting the classes. You know, a single class is useful, sure. But the real power, the magic of a system, comes from how dozens, or even hundreds, of these classes all work together. And the lines connecting them on the diagram, those show us these absolutely critical relationships. Yeah, these classes don't live in a bubble. Their connections literally define the entire architecture of the system. So let's kick things off with one of the most fundamental relationships of all, inheritance. Inheritance is really just a fancy way of saying an is-a relationship. It's super intuitive. For example, a tortoise is an animal. It gets, or inherits, all the general things that make up an animal, like having a name or an age, but it might also have its own special things too. In the diagram, you'll see this as a solid line with a hollow arrowhead pointing up to the parent class. Okay, next up, let's clear up the difference between two ideas that sound similar but are very different: aggregation and composition. Aggregation is a has-a relationship. A tortoise has a place in a group of tortoises. But if that group breaks up, the tortoise is still around, right? It can exist on its own. Composition, on the other hand, is a much stronger owns-a relationship. A visitor center owns a lobby. If you tear down the visitor center, the lobby is gone too. The part cannot exist without the whole. And now for Section 4, a real-world example. We've gone over the individual pieces and the lines that connect them, so now let's see how this all comes together in a complete blueprint for something you probably use all the time, an online store. Okay, check this out. Let's imagine we're looking at the blueprint for an online shopping system. You'd have classes for everything: customers, products, shopping carts, you name it. We're going to break down a few of the key relationships you'd find in a diagram like this. So right away, you'd probably see a customer class and an administrator class. And notice how both of them would inherit from a more general user class. That makes perfect sense. It means they both share common things like a user ID and a password, but each one also gets its own unique abilities, like a customer can place order, while an administrator might ban user. And look right here. See this filled-in diamond? That's a huge clue. That means composition. This tells us that a shopping cart is fundamentally owned by a customer. It has no reason to exist on its own. So if you delete that customer's account, poof, their shopping cart is deleted right along with it. That ownership rule is defined right there in the blueprint. And here's another little piece of notation you'd see everywhere: multiplicity. On the line connecting a customer to their orders, you probably see something like 0./*. This is just a simple way of saying that one customer can have 0 or many orders. You can have an account and never buy a thing, or you could be a power shopper with hundreds of orders. That tiny bit of text defines a critical business rule. Which brings us to our last section, Section 5, why blueprints matter. I mean, why go through all this trouble of drawing diagrams before you can even write a single line of code? What's the big payoff? Well, the benefits are absolutely massive. First, these diagrams create crystal clear communication, not just for developers, but for business folks too. They help you find major design flaws before you start coding, which saves just a ridiculous amount of time and money. They become the roadmap for actually building the thing. They serve as documentation for anyone who works on it later, and some tools can even generate starter code directly from the diagram. It just makes the whole process faster, cheaper, and leads to a much better final product. So I'll leave you with a question to chew on. The next time you open up your favorite app, I don't care if it's social media, your banking app, whatever, try to imagine the blueprint running things behind the scenes. What hidden classes, what secret relationships and structures are all working together to make that experience possible? Thanks so much for joining me.